Well, hello there, everybody, and welcome to Skyter livestream for this evening. It is I, Mark D'Antonio, here to bring you hopefully an enjoyable evening. Our computer is not performing very well; it's doing stupid stuff. But before I do that, let's move on and tell you who else is here, and that would be Daryl Mason. Hello, Daryl. How are you?
Hello, Mark. I'm good, thanks. You? Hello, everybody.
I'm doing well, thank you. I'm just working on a few little items here while we wait. I see a bunch of people here. It's good to see you. I gotta warn you, the computer here in the bunker has been freezing up out of nowhere. It's a brand new behavior that I absolutely hate. So we're gonna hope that it doesn't do that. But if it does, you'll see a sudden stoppage, and you won't know why, and neither will I. And I don't know that we'll be able to restart it when that happens. So we'll do our best. Okay, I'm working on a few things. Okay. Alright, just a minute here. Okay. Getting a few more things ready. So how you doing, Daryl?
Oh, I'm good, everything considered. I fixed my clothes dryer,
That's
and
good.
it rained all day, and we even had thunderstorms, which was interesting. And
Wow.
uh, then I went out to check the mail, and it's snowing.
that is not. That is not. I don't want to hear that. That's no good.
Yeah, well, that's Colorado. It was in the 80s here a couple of days ago, and now it's snowing.
Wow. So it was in the 80s, and now it's snowing.
Yeah, and
Uh,
which is more unusual is the 80s part this time of year.
okay.
Typically, April is the second snowiest month here, and usually the weather sucks here in April. But
All
we had
right.
several days of it was decent outside,
Gotcha.
and we need the moisture as always. So I'm not going to complain.
Yeah.
Just a good night to stay indoors, good sleeping weather.
What was the day like today?
Cold, rainy, thundery, then snowy.
Gotcha. Cold and miserable.
Yeah, well, maybe if I'd been outside in it, it would have been
Yeah.
miserable. It was just a good day to stay indoors.
Got ya. Got ya. Very nice.
I think Izabela told your bad computer to sit.
I hope that it listens. I hope it listens. Yeah.
Sounds
So.
like she's talking to her dog.
Okay. Well, let me just explain to folks what's actually going on. The computer is probably showing signs of faulty memory. So I have new memory showing up tomorrow, and that memory is going to replace the memory in the computer, and we're going to try to see if that's what's been causing the computer to simply freeze. I mean, you might catch me like this, and then it'll be frozen, you know. And cursors and things that I normally show you things on the screen, they'll just freeze and I can't move them. So I'm hoping that we won't have that issue. It's still getting dark out there. Our planetarium program shows us the state of affairs for the darkness of the sky out there. It's actually quite accurate. You can see we still have some orange glow. If we were to take pictures right now, we would see an orange glow in our shots. But what we want to do is tonight, before we do anything else, as long as the computer behaves itself, I want to take us to a last look at the Orion Nebula before it goes, because it's actually pretty low, but we'll be able to check it out.
Can you pull it over a little bit north of west for just a second.
What? Pull what over?
Still there, man.
Oh, yeah. Let me tell us to get here.
Okay.
Okay, so you'll watch the telescope move here in just a sec. There it goes. Look at leaning way over. All right, so if we're going to go north and to the west, we're going down here.
Just a little bit north of west.
Yeah, getting
Venus is what I want to say.
there. Oh, okay.
See if it still shows Mercury.
We'll see. Let's find out. Yeah, there's Venus.
Yeah, there's Venus, and Mercury's behind that tree, or
Yeah.
down already.
Yeah, it's down already. Yeah. I actually did look at Venus the other day, and it was, of course, it looks like a gibbous Venus and very, very small.
Yeah.
Because it's on the
like sort of lemon shape.
Yeah, a little less than that. Yeah.
Yeah. I saw an interesting thing a day or two ago, sort of a sign of the times.
Mm-hmm.
You know, it used to be people would see Venus, and if they didn't understand what it was, they'd often report it as a UFO.
Oh, trust me, I'm very familiar with that.
Yeah, some guy posted a picture in Reddit from here in Colorado, oddly enough, and he called it a drone. He said it's been up there the last 2 nights. About a dozen people piled on him and said that was Venus, but
yeah, it's Venus, but you know what? That's okay.
yeah. Actually, Venus is in Taurus now, and it's right between the Hyades and the Pleiades. It was very close to the Pleiades a day or two ago.
Yeah.
Excuse me.
So here in the Orion Nebula, the heart of the Orion Nebula, we have these 4 stars. And these 4 stars are called the Trapezium. You can see how the hydrogen and the oxygen in the center of the nebula is caused to glow. It's not illumination. There is some illumination of dust in there, but it's mostly a reaction where that's caused by ionization of the hydrogen and the oxygen. And the ionization causes those atoms to glow, in short. So that's what's going on here. I'm just looking here to see what the focus range is here. See where we sit. Let's see if I can focus. Okay, that's good actually. So I'm going to do an autofocus as well in just a minute. But I want to see. Yeah, see it gets a little better there. It'll dump in just a little more. Yeah, that's about right. So it's in between these 2 objects, these 2 points. And so what we're going to do is we're going to come out a couple of runs like that. Actually, I'll go in one. Okay, and now what we can do is bring up our autofocus system, and it's going to grab a bunch of stars in the overall field. And we're going to scan inwards until we see a bell curve, inverse parabolic curve actually, indicating the best focal point, the best focus point for us. This is all good. All right, so let me back out of here just for now so you can watch that happen. And there you see the other stars in the rest of the field that are being used for our autofocus setup here. So I want to say hello to everybody that's here. Thank you for coming. I see Yasser was here first. Nice to see you, man. Cyclone is with us. PG, that's Petita in Pennsylvania. Michael Hedrick, how you doing, Michael? Judy M is with us. Terry Haig, hello, Terry. And we have this Daryl guy again. And Daisy and Zoe Amethyst are with us. And we have Lucy Clark. Hi, Lucy. Nice to see you. And let's see what else we have. I saw somebody different. Alice Pooper's with us. Nice to see you, Alice. Lucy is here with us again today. I think I told Lucy that I wasn't going to do this tonight in the chat, and luckily I changed my mind. Hello, John Proctor. How are you? Good to see you. I want to actually, while John is here, I want to make a comment and show that we actually have John Proctor is one of our benefactors for the Patreon. Izabela, Holly B, Chief McCyber, Vera C, Ronald T, Martin W, Raymond B, Cindy M, and Terry H. I want to thank all of you wonderful patrons, and we only need about 1,000 more. And then we can really fix all the little problems that occur once in a while. Okay, so we are going to go to a best focus position now, because we can.
Could I ask a dumb question?
There is no dumb question, but go ahead.
The arrows in the parabola down at the bottom.
Yeah, they actually didn't go where they're supposed to.
Why are the colors different?
It depends.
White on the right.
Yeah, that's weird.
Toward red on the left.
Yeah, that's a strange thing. I'm going to actually reset this and do it again, because I think that maybe what's happening is we didn't get enough stars. So I'm going to bring us back out. Okay. So what I'll do is I'll scan out now and grab our focus that way. And you'll see now that when I scan out, we're going to get green triangles. If I scan in, we get red ones. It's a standard for this system. I'm not sure why Robin did that. Robin is the guy that wrote this program. He's very responsive too. When you ask him questions, he'll tell you why he did things a certain way, and he'll take your suggestions. Some of the suggestions I suggested are in the software now, which is very cool. Remember, guys. Oh, hi, Sam S. I see Sam is here as well. Remember, guys, and Izabela, I didn't see you before, and I knew you were here. James Glupka, how are you? You're in Palm Springs. Hey, I will be in Palm Springs in the early June. I will be there doing a talk at Indian Wells for Contact in the Desert. So maybe if you're going to be there, we can say hi to each other. Hi, Alpacas is here. Hey, man, how you doing? Everything is really blurry on his end. Okay, you know what? Make sure what you do is you take the you take your resolution and set it to 1080p. Right? So you go down the bottom of your YouTube feed and you set it to 1080p. Okay, that's gonna make everything not blurry. Right? If it's blurry, you can also have a problem with your internet. And so make sure you do go to HD. Michael Hendrick is suggesting that as well. Okay.
It could be blurry because you're running a focus run.
Well, I think that he was responding to everything, like the words and everything is blurry. He just needs to go. That's my thought, actually. All right, there's the Orion Nebula. Beautiful focus. And what we're going to do is I'm going to do a short exposure. And why would I do that? Because I want to show you some of the details in the nebula and show you some of the colors. So this is only a 6-second exposure, and we're going to live stack that. All right, so let's see if we can clear this. All right, that's good. Stacks reset. And then we're going to get rid of, sorry about blowing out your eyes there, guys. Then we're going to move our lines around and then change our colors to the more proper colors. We're still dealing with sunset, so that's why we have a little brightness in here right now. But look at those beautiful colors. The Orion Nebula is stunning. It's just one of the most beautiful nebulae in the sky. It's the only one you can see with your eyes. And it's just below Orion's belt in Orion's sword. Okay. All right. Now, I gotta warn you, like I said, if something happens and the computer goes down, what I don't know is if I can still be talking to you. Maybe that'll still be coming through. I'm not sure. And if I can, that's wonderful. If I can't, then thank you for coming. And I should have it fixed tomorrow. But I couldn't let this night go without trying to show you something cool anyway. Yeah. Yeah. The Orion Nebula is around 1,500 or so light years away. About 24 light years across or so, I believe. That's from like here to here. And so that 24 light years is approximately from here to here. You can see my diagram here. All right. And then we have some beautiful features within there. Okay, this is something that's called the Bay right here. It's an area where it's actually right here where there's an overlying dark nebula that overlays, and it actually overlays the bright nebula behind it. And we can't see that here, but it actually let me do this. It actually extends way out into this area. You can start to see a little hint of it, even with the sunset light that's still affecting our view right now. Let's see if we can. Go ahead, Daryl.
When you see the bay there,
right there.
They used to call that the fish's mouth.
Right here?
Yeah.
Yeah. All right.
Because it looked like a fish's mouth.
All right. Okay. But if I pull us out here and you get a little more detail in here. Again, we're low to the horizon, plus it's not quite dark yet. You can see that there's also dust out here. All right. And that's just something that we deal with the Orion Nebula. This is, again, I just want to show you the Orion Nebula one last time. When it's fully dark, it'll look really pretty. And if I hate to say it this way, if our computer lasts that long tonight, we'll be able to explore that with you. But all these convolutions you see, this is all the gas that's illuminated. That's glowing as a result of those 4 stars that are now buried inside this bright white area. This bright white area is actually green and a little red, and that's the ionized oxygen in here that's causing that glow that's green. The reddish glow, this is actually a little too red. If we were to drop down the colors just a little bit, it was to be more realistic. Let me see if I can do that. So I'll bring them down a little more. This looks pretty good. Let's color balance and do another. Yeah, that's more like it. Now you can see the greenish blue here. That's the oxygen, and you can see the hydrogen gas that's glowing. Okay, ionized oxygen looks green and greenish blue, mostly green, and the hydrogen looks red. This dark stuff is dust, and there's no gas in there, so there is no glow caused by that. You just have light striking it, and sometimes it reflects the light back. All right, but sometimes the dark particles will scatter the blue light from the star, or a star that's in the area, and then you get what we see up above here. And what you see up here is the Running Man Nebula, and I'll show it to you. Okay, there it is. It looks a little faint now because all I did was, this is only a 6-second exposure, by the way. This was to show you some of the structure in the nebula, the colors. But now, let's come back and let's do a 15-second exposure. All right, so we're going to clear this. Actually, let me save it just like we have it. And let's, that may not work. Let's try it. M42. Save. And save exactly as seen. Okay. Okay, now we'll clear and do another one.
We should do the Horsehead tonight, too.
I'm gonna, right after this. Okay, that's a perfect thing because we're gonna close that out, too.
Yeah, we had somebody asking about it.
All right. Hello, James Hyatt. How you doing?
Bonnie's here.
And Anahata77 is Bonnie. Hi, Bonnie.
Oh, Bonnie.
Yeah, let's do this while we're taking this picture. Let's bring that out of the way. And why don't we actually get rid of the telescope for now and maximize our view. Here we go. Look at that. There's a beautiful Orion Nebula. Last view of the season, folks. And that's a beautiful nebula. Now, again, this is the one you can see with your eye, and it's literally right below the belt of 3 stars. And you can see it with your eye. It kind of looks like a little fuzzy light down there. You know, it's really cool. Yeah.
If you see the 3 stars of the belt of Orion by eye, look beneath them, and you'll see a line running at a steep angle, if not perpendicular to the belt, and that's Orion's sword. And the Orion Nebula is the middle star in the sword.
That's right.
Michael Hedrick wanted to ask you about the runaway black hole.
Oh. Okay, and that's the one that's in this area?
I don't remember where it is. It's the one that's leaving a big long trail of stars behind it.
Okay. 1 second here. Let me just pop this out. Pink. The Orion Nebula. Okay, that's our label for what we're looking at right there. All right, and while we're here, I'll just come in and go here and just pull our black level way over to the left here, so I can show you the more detail that's really out here. Now that's pretty cool. All right, so Michael, you asked about the runaway black hole. What do you want to know about it, Michael? I actually don't have a whole lot of data on it at the moment, but I could look all that up, or Daryl could, you know, while I'm doing this. But I wish I had more data for you. I know that there is a runaway black hole, and I saw the images showing it, this trail of stars that it's creating. Very interesting phenomenon, actually.
Yeah, Michael, you know as much as we do probably if you've heard about it. I believe the black hole was ejected from a galaxy and it's streaking across space and it's dragging a long line of stars behind it.
Yeah, it's not making stars. Let's be clear, okay? And that's not what Daryl's saying, of course, but it's actually dragging stars with it, and as a result of its massive gravity, okay, it's like the Pied Piper of galactic Pied Piper, you know.
It's a good way to put it.
Yeah, I hope so. All right, let's bring our dock back here. I'll leave this at full screen for now, but I want to show you. I was talking about how the green is from oxygen, the red is from the hydrogen here, but then we also have, you know, if we look here, we see that we have like blue up in here. All right, so that blue is actually caused by small particles of dust, and this whole area is full of it. If we move this back, right, say here, you can see all this dust in here. And again, we're very low to the horizon right now, so the view is not the best for us. But this dust is scattering the blue light from the stars in this region, and it does the same thing that our sky does. Our sky molecules of nitrogen and oxygen, they scatter the blue light coming from our sun, and so that's why the sky looks blue. All right, and it lets through the light that's left over, which is more toward the red end of the spectrum. So at sunset, when we're looking through a lot more light, a lot more atmosphere, more of that blue light is taken out, so that the sunsets look red to our eyes. Very interesting stuff. But you can see these beautiful clouds of gas and dust here. All right, so this is good, and we're gonna stay with this. We just did 20 frames, so we're saving it as our astronomical file. That's a FITS file, and then we'll save it exactly as seen, just like you see it here. Now, it's going up to our server that you can find at skytourlive.org. And if you scroll down just one section, it takes you to the actual server data, and you can look at tonight's image that you see here. That'll be there probably in the next 25 seconds. All right, so that's how that works. We know what that is. All right, one more time. Let me just adjust this. Okay, and we'll save that just as it shows here.
I found a decent article about the black hole.
Okay, cool. I'm going to take us to the Horsehead while we're waiting.
Okay. Well, as I said, they think it's a supermassive black hole. I think they said like 20 million solar masses.
Okay.
And it got ejected from a galaxy. Evidently, they think there were two other supermassive black holes, and when you mix three black holes, I guess you get a chaotic situation, and one got ejected from the galaxy. And this article,
right,
which is in Scientific American, says evidently the black hole is actually forming stars. It's not just pulling them along behind it. It's plowing through a rich field of intergalactic hydrogen, and
okay.
its passage is disturbing the gas and causing star formation.
That makes a huge difference.
So, I'll post a link in the chat.
Okay.
And now, Michael, you'll know as much as we do.
Okay, there is Alnitak and the Flame Nebula, and we're going to move south a little bit and pull up the Horsehead Nebula for the last time of the season.
I used to subscribe to Scientific American.
Yeah, I did too. I think everybody did at one point.
Yeah, I gave up on it a long time ago.
Well, my wallet had to give up on it a long time ago.
That too.
It became too expensive. Well, let's be fair. I was in all these books of the month for all the different science disciplines, and I started them like when I was 10 years old. So I amassed quite a library, as you can imagine. I had 4 to 6 books a month coming for like 15 years. So I still have many of those books here. But a great deal of them got destroyed when there was a flood here. And everything was on pallets, but the water rose like 1.5 feet in the basement, and it went way above the pallets, got to the cardboard boxes, and all the books were cemented together like blocks of concrete. So I lost several $1,000s worth of books. That's the way it happens. Okay, let's do this now. Let's go and do let's do 25 seconds here. And let's do a live stack on this as well. This is the Horsehead. That's Alnitak. That's the leftmost star in the belt of Orion. Alnilam is the next one. It's just out of view up here. And beyond it is Mintaka, the third star in the belt. All right, so we're going to do this, and no, and clear. All right. This is a new stack called the Horsehead. And it will show up on the server in that name.
I used to subscribe to so many magazines, and I was like you, I books out the ears, and
Oh, yeah.
I still have box upon box full of books out in my garage, and
As do I.
I actually canceled my last magazine subscription recently.
Wow. Well, there's the Horsehead right there. Again, low to the horizon. And there is the Flame Nebula. Now, we're literally in the last vestige of astronomical twilight here. So we've got a little ways to go here, just a few more minutes before it's fully dark. So we're getting an orange cast here, which is making the hydrogen look redder than it is. So that's just, how that works. But compared to what we've done before, you've seen some really gorgeous images that we've produced here. And so it's we're at 250 gain. I might have showed you this before, but I'll do it again. Okay. For those that haven't been here before, this area over here in the red box, that's our telescope control. This is our telescope computer. This is the telescope out in the building. This is me. Hello. Ta-da. Okay. This is our stack window. We're taking photos and stacking them on top of each other and bringing the data out over time and getting rid of noise that generates inside. This is our camera control cluster over here. And this is our focus system right here. The rest of these things are other stuff that I do. Now, the thing that's important here is there is two features. The most important thing here is the exposure right there. Okay. And then the second most important thing is the gain right here. So the gain of 250 to 300 is what we run. That's the sensitivity of the sensor. The exposure is how much time we expose to that sensitivity. And that gives us our image. So that's where we go with that. And as we adjust this here, yeah, you can see there's a substantial red component over here for the sunset still. But look at the Horsehead Nebula. Looks really pretty. Really pretty. Let's see if we can correct. So there's a color correction to kind of show you what it should look like. That's nice. That's looking pretty nice anyway, huh? For being low to the horizon still.
I would say so, yes.
Yeah. In the Horsehead Nebula here, okay, you can see there's little stars right at the top here. There's one right there. There's one right there. And what we can do is we can soften the noise just a little bit without compromising too much. But again, being low to the horizon, it's actually not the best viewing, but we'll catch some good viewing tonight. As of now, I'll say this. As of now, I'm okay with what we're seeing here, because as of now, the stream is a success. So if it hangs, well, we got a few minutes together. And that's okay. Nice. This is nicely nice. Alright. Oops, sorry. I clobbered something. Okay, good. So who else is here? Did I miss someone? Hey, Cosmic Ray is with us tonight. And James Hyatt says, the Horsehead was one of the first nebula I ever saw when I got my first telescope. A long time ago. Yeah, long time for me too, James. Long time for me as well. Very cool. I'm glad we could pull this off tonight. I wasn't sure we could. And Izabela put the link up there for the Orion Nebula on the server, and I'm sure that someone will do that for the Horsehead as well. Donald Kunzer, how are you? Good to see you. Look at that. So this is so delicate in here. You see how delicate this stuff is? This is really beautiful. Now, one thing that is worth mentioning is this star right here is known as Sigma Orionis. Sigma Orionis is a hot blue star And it's actually more than one star. It's a multiple star. Many are. And this star is so powerful that it's actually causing the hydrogen here in this wall of a molecular cloud of hydrogen, carbon, and silicon atoms and more, causing this hydrogen to glow and ionize. So this is several light years away, and it's really doing a number on this area. And because it's causing this to glow, we get to see the Horsehead Nebula silhouetted against it. This is a little tongue of dark nebula sticking out of this gigantic wall of dark nebula here. Again, this and this stuff here overlaying the Flame Nebula, which you can see is intricate here. And then the stuff that we see down here, this is a reflection nebula, or that scattering nebula I told you about. The star's blue light is being scattered by dust in here. Same here. And this dark nebula is all throughout here. This is called the OMCC, the Orion Molecular Cloud Complex. And it's pretty cool. Pretty cool. Hello, Trish Ferreira. How are you? Thank you for joining us tonight. And for you guys, if you haven't, make sure you subscribe, huh? So subscribe to SkyTour live stream on YouTube, and go here. Go to skytourlive.org, and we appreciate any patronage if you feel like subscribing to us and getting some really cool pictures. Our Patreon gives you access to the highly processed imagery that we do after the fact. So you get to see images like this and take them down. Yes, you do. Those are free. But if you want to get some really cool pictures that are just mind-blowing, then go here to skytourlive.org and go to the upper right to the Patreon and join us. For a minimum of $10 a month, which is actually 2 Starbucks coffees now, or drinks, you get 4 beautifully finished images per month, and more. We also have products that we'll be offering soon enough. Among them, I have some really cool objects here. Let me just show you. Just a second.
You're cutting out rather badly on me, Mark.
It's probably not to everybody, though. But we'll see what happens. Okay, so this you can't really see, but I'm going to show you if I can. I may not be able to show you as well as I want to. These are sneakers with a nebula on them, and it says skytourlive.org on it. These sneakers, we make mouse pads, we make cups, blankets, lamps. The shade is a see-through shade. You can see nebula like the Horsehead Nebula coming through. These are stunning products done with our own photography. So I would hope that you might like to join us. If you actually want to buy them, we're going to have them in a store before long. And then we are going to, there we go, that's better. We also are going to start offering them as part of the Patreon. So for a certain amount, you get a certain thing. You know, we have playing cards, we have everything. It's crazy how much stuff there is. It's just incredible. But go to skytourlive.org and check it out. You know, look at all this dust. See all that dust out there? And this is overlaying this nebula here, and this is sticking out over here a little bit. You see more stuff out here. It's absolutely astonishing how much that is. How much dust is there. But again, that's the Orion Molecular Cloud Complex. It's always pretty, Daryl.
It always is.
Yeah. And by the way, thanks for joining us tonight. Okay, this is good. So we'll save this. That's just what we want.
Okay.
Yeah, thank you for coming out. Enjoy it.
I usually do.
I know, but I was just thanking you for joining us tonight.
Well, thank you for thanking me. Or you're welcome, or
right.
whatever I'm supposed to say.
That's fine.
Glad to be here.
Cosmic Ray, thank you for mentioning that. We are simulcasting now. This is not just going on YouTube. This is going out to Facebook. It's going out to Twitch. It's going out to Trovo. It's of course YouTube, and soon it'll be going out to Rumble. So, and we announce on Twitter when we go and it's announced on Twitter as well. So I think that I think that it's pretty. We're getting some pretty good coverage, but we're growing. We're growing. We're a non-profit corporation now, and we're doing that so that we can try to get some foundation funding to really bring you some very serious imagery with very serious. This is not hay right here. This is beautiful imagery, but we have one scope you can't see that's behind me. That's for the East Coast. We have this one here that's out in the desert, and we have a third one going in out there as well, and that one is going to be able to zoom in so you can see just one small section of an object. So you'll see this beautiful thing, and then right next to it you're going to see an inset that shows what the other telescope is looking at the same time. So we're going to have all these telescopes moving to the same objects at the same time all across the country. So it'll be pretty cool. Let's see what anyone says here in chat, if anyone has any questions. Okay. Well, this is good, and I'm just going to do one more. Mouse like that. Do this. Okay. And now we're going to save that. And save it exactly as seen. There we go. All right. So there is our last view of the Horsehead and the Flame, and of course the leftmost star, Alnatak. You can see this little glow here. This is the glow of Alnilam, the middle star in the belt, which is breaking into the view a little bit over here. Okay. So good night to the Horsehead. We'll see you next season.
Good morning, coffee machine. Izabela went to get some coffee.
Okay.
Well, if we're saying goodbye to Orion, you ought to say goodbye to Casper and the Boogeyman, too.
That is possible while we're waiting for other things to come up. Yeah. So right about there. Let's move this to the center. Let's zoom in a little more. And of course, we have the Rosette, the Christmas tree cluster. It just doesn't end. There's so many things to see. But we could do that.
Oh, you don't have to.
Well, I think that's a good idea. There it is. Casper, the Friendly Ghost Nebula. It's right there. And it's right nearby. So we might as well go to it. It won't be a very good view, but we can at least check it out. And there goes the telescope. Zing! Just to the upper left a little bit. And you'll see these fuzzy little stars, which let us know that we're in the region. Okay. This is our night vision mode. That's what you're seeing here. So this is night vision mode. So we can actually see where we're going and see the objects we're going after. Okay, and there goes a satellite, probably a Starlink satellite. I'm going to increase our sensitivity now to 300. Remember the gain over here? I set it to 300, and this is going to be a exposure that's going to be 35 seconds. Now, what's that mean, 35 seconds? It means we're going to expose it for 35 seconds at that gain you see of 300. And then we're going to take another one and align it and stack it on top of the first. and do that again and again and again and make an image sandwich, and all the faint detail will rise to the top and all the noise will get left behind. So we'll actually see very clearly what the nebula looks like. All right, and this we'll get rid of, and that's our last one we just saw. And we clear the Horsehead here and get ready for Casper the Friendly Ghost. And there it is. And the red, of course, is not the correct color. That's the correct color. Now, this nebula shows some amazing characteristics. It has a lot of dark nebula, and this is that reflection nebula, or blue scattering nebula that we talked about. And then over here in the corner is the right-hand side of a large supernova remnant that's in Orion called Barnard's Loop. And it's something that we have seen before. But it's something that is actually quite astonishing to see when we actually take the time to image all of it. And we've done that. We've done that. You know. So right now, Casper the Friendly Ghost. There it is. Oh, look at that. Casper the Friendly Ghost Nebula. Oh. That's kind of weird. Get rid of that. Alright. And a Starlink satellite. Thank you. But, I got to admit, Starlink is the reason that we can do this right now. We used a much slower service, and Starlink gives us much more latitude to do this. We used to, like, see how I'm moving the mouse right now? I'm moving the mouse on the screen, and like moving lines like this one here. These are they're called the level lines. They tell you like how much of the data we want to intercept with this yellow curve, and the more we intercept, the more we see. So you see more of this dark nebula in here, but you'll see how fast these are actually moving. When we're using the other system, I'd have to wait 3 seconds from the time I initiated the move to the time it would actually show up. Absolutely disgusting. And now we're at about 10 times that speed. Here you can start to see this beautiful nebula coming in here. You can see some fingers of it coming down here. Even as low as we are on the horizon, we're seeing them. Now you might say, oh, that line sucks, that's terrible. Yes, it's true, but it's the only frame, only one frame out of all the ones we're stacking has that on it. So the next one that comes in where it's dark in this location, well, that dark is going to get added to this white line as well in that spot. So what you'll see is these lines fade over time. So the more we stack, the less prominent that line will be, and it will go away. Now, if we were capturing individual frames, which we could do and have done, we could then remove it and then stack later. But I'm stacking right now dynamically for you because I want you to see the beautiful objects right before your eyes. You know, that's why we say SkyTour live stream is the universe live in real time. This is live, real time. And that's the thing that's beautiful. If something were to happen right now in this nebula, we'd see it.
It's early yet, too. It's not even astronomical twilight yet in Arizona.
Yeah, I know. And that's why, and we're actually in that, we're in the western sky, so it's still got a little brightness to it. But I figured we get started now, right?
Sure.
Take advantage of the fact that my telescope's working. I'm going to pop that off right now. Come here, you. We don't need the name at the moment. Because you know what it is. And if you don't, that's what it is. And away you go. All right. Okay. So we've stacked 7 here. 35 seconds at 300. The higher up you go with this gain here, the higher up you go with the gain, the more noise ends up in your image. So we would have to stack a lot more to get rid of the noise. But what we're doing now, this is pretty good. Oh, Huey Burrito. The Twitch handle is STLS. And I think it's either STLS or STLSW. Sky Tour Livestream W. And I know I can probably dig that up, but I don't want to mess with this computer right now because it's working. Yeah, Cosmic Ray Smith, it says smash that thumbs up button. Yeah, please do, because we would love to have you guys, here with us for a long time to come. Cosmic Ray says, Casper the subpar nebula. Well, if you were lower the horizon, you'd be subpar 2, I guess. But look at all this detail. Look at that detail right there. Let's zoom in on that. Okay, I want to show you. See, this dark dust is sprinkled throughout the galaxy. And look at these delicate little tendrils, these delicate tentacles that are superimposed over this bright nebula within. It's like spider silk, and the spider is woven a web around the central core. That's kind of what this looks like. You know? Not bad for being that close to the horizon. And we can just pull this back in. Yeah, look at all those little tentacles of this. This is really pretty. Ah, yeah. Hey, Rocket City Astro, how you doing? Thanks for coming out. Okay.
Does anybody remember the name of the other ghost on Casper, the friendly ghost?
Oh.
He was the tough one. Wore a little derby hat, and he looked Irish, and he was...
Do you have a cigar?
I don't remember.
Didn't he have like a big fat cigar that he had in his mouth?
Like he was always spoiling for a fight.
Yeah. Another satellite came through. I don't remember the name.
Spooky.
Oh, okay.
I do believe.
All right. James Hyatt says, thank you. It's the first time I've seen this one. Very cool. Happy to show you. Alabama Constitutional, what are you doing? Good to see you. Spiders, eek. Yeah. Yeah, this is looking pretty. And then again, we'll see better views with objects that are more higher in the sky. So thank you for hanging out for this. Okay, we will wait for the 15th image, and then we will save it. I'll call this what it is. It's actually called Measure 78. And we'll call it a Casper. It's a reflection nebula, as we call them. All right, so save. And that saves up to the server, and then we save it. Before I save it exactly as seen, let's see if we can do a little work on it to give it a little more processing. Okay, let me do a color correction. There we go. And I will save that exactly as seen. Okay, there we go. And it's actually outlined by this little strange geometric convergence of satellite trails. That's neat. Okay, so we'll come out of here, go to our next object, and we'll go to our night vision mode here. And I think I missed my timer. There we go.
Are you there?
Yeah, I'm here.
Oh, I thought we lost you.
I know, right? Now that I got you worried about it, I don't want to be worried about it.
You started to say you missed something?
I missed my 1 second timer, but I've got it back. We're good.
Oh.
Okay, so this is our night vision mode, as I mentioned, and so now what we'll do is we will go to the next object by going to our planetarium program, but first we're going to move down a little bit here. Go to our... There we go.
See, even Solarium spelled it Casper with an E.
Yeah, it probably is Casper, that with an E. This is the next one we'll go to because it's getting pretty low. So we're going to climb up in the sky and go to the Rosette one last time for the season. And there's the Rosette. The Rosette is a beautiful cluster, but it's a cluster that is young and hot, and what it's done is it's carved out a cavity around the cluster, which is what these stars do. Being an astronomer, when I went to school for astronomy, we learned all about the radiation output from these hot young stars and how they would actually make a cavity around them and start pushing all that gas out. And it's pretty cool how it works. So I will be taking a picture now of this just so you can see. We're guiding now. This is our guider, our auto guider. Our telescope is guiding now. This is a little higher in the sky, so this might look a little better. We still have a few more minutes, I think, of astronomical twilight before we actually are considered dark, but I think we'll be okay. I'm going to do a 35-second shot of this. And live stack it.
Astro Twilight was at 8:29 p.m.
All right, so we're right there. I think we're right there. All right, we're doing a 35-second exposure of the Rosette Nebula. Rocket City says, I'm going to be going live Monday night with the new telescope. Ooh, and then you asked what he had, and he has a Sharp Star 130mm f2.8 imaging Newtonian that has a hyperbolic mirror. Well, that'll be very cool.
Sounds like collimation will be critical on that.
I'm imagining you're correct.
F2.8 Newtonian.
Ooh, look at that. That is the beginning of a beautiful shot. I may have to start it again because I may have not waited for the guiding to stabilize. Let's take a look. Yeah. There's a lot of noise. See that's noise in there? But just watch now. As the second one comes in, watch what happens in here. Here it comes. Okay. So now, look at, see how much of that noise goes away? That's from stacking just 2 images. Okay? You stack more of that noise goes away. More and more and more until finally you have a really, really, really good tight shot. With lots of signal and very little noise. So if we back out now. And now that's a more subtle view of it, but it shows you the subtlety here. Look at this beautiful little segment over here. Okay. If you'll notice, in this nebula, you can see these stalks. And they tend to be pointing at those stars, don't they? That's no coincidence. There's no coincidence. This is because these stars are really, really hot and bright, and they have radiation, that's radiative energy that's coming down on this gas and dust These are dust spires here, and there's hydrogen gas mixed in with them. And the hydrogen is ionized, so it glows red. But the dust is usually dark. And what happens is, where it's densest, like here, all right, if we'll zoom in and see if we can support it at this early stage of the exposure, where you see it, it's kind of here, it looks like it's a dense knot. And then it trails behind in like a little finger. That's what we call a stalk, okay? We see that like that over here. We see that elsewhere in this nebula. And what's happening is this is dense, so the star's energy can't obliterate this with just that push of radiative energy. What it does, though, is it creates a safe haven on the backside where material is not pushed out of the way. So it tends to make a long stalk. Okay, because the radiation from the star can't reach this either. If it can't push this out of the way, it's not going to push out what's behind it from the star. So that is what we have going on in this nebula. And the cavity I told you about is right here. It's really obvious. Okay, inside this beautiful nebula, all right, we have this cavity that's been created by these young hot stars. And it's pushing outward in all directions. And it's clearing the inside of the nebula. And that's just what clusters do. All clusters form in these stellar nurseries like this. And then they push that gas away. And then finally the gas is so sparse that it no longer shows up as the glow, or it gets so far away that the stars can no longer ionize it. And thus you have a cluster of stars all by itself. You know, and that's what we see in a lot of places. Clusters of stars all by themselves. Hi, Prow. How you doing?
Michael Hedrick has a question of you.
Uh,
Do we know how powerful other stars' solar winds are? Does it
oh,
depend on the type of star?
yes, absolutely. And I think, Daryl, you would have said the same thing.
I did say the same thing.
Oh,
He
okay.
wants your answer.
Oh, well, if you said it, you say it in the chat. I missed it if you did.
Yes, I did.
Okay. Michael Hedrick, the O-type stars. I remember they go hottest to coolest, right? And that's O, B, A, F, G, K, and M. And the O stars are also hot and blue. So they go from blue down to white to yellow to orange to red. Okay? And the hottest and the bluest stars have the most powerful stellar winds. And the stellar winds that are propelled out of an O-type star are so powerful it would sear your face off if you were somewhere in the region of like a light year from them. It'd sear your face off. It's really got a lot of powerful winds. All right. The Bs are less so. For B stars, O stars? What are examples? Alnitak, that we just looked at. Alnitak is an O star in Orion's belt. Betelgeuse, that red star you see, used to be an O-type star. And then it evolved. And as it evolved, it ran out of hydrogen and started doing other things. And part of that process in stellar revolution is it grew into this red giant, a red supergiant, which is what it is. It's on the verge of a supernova. And maybe it's already gone, supernova, but we won't know about it for 750 years because that's how far away it is. And its light takes that long to get here. This is looking really pretty. I'm going to add an enhancement now. All right, watch the detail in here. Ready? Watch this. Look at your screens. Here we go. Look at that. Now you can see much more detail in here. Now that we have a lot of images stacked, we have 10, we can see some beautiful details in here now because we added this filter that's called an unsharp mask, actually. Now you can see those stalks really clearly. Right there. That's pretty. That's really pretty.
Mark Cosmic Ray expanded on Michael's question. How are stellar winds measured around other stars?
We have theoretical models, Ray, and for instance, we know that O stars have copious stellar winds. Much of their radiation is given off in the ultraviolet because they're so high frequency. And based on the models, predicted by the temperatures required for an O-type star to exist and for the O-type star's processes to go through what they do, we can calculate the output radiation. In fact, there's a book by Ivan Novotny called Stellar Atmospheres, and we use stellar atmospheres to help model building stars and figuring out what their output per square meter was. And it was a real computationally intensive process. But you could do that for O stars, B stars, all the way down to M stars. And what they don't account for are solar flares. Solar flares are spurious events which can cause a huge amount of stellar wind in a very short amount of time. And they also can cause particles to be ejected from the star and slam into planets, and that's called a coronal mass ejection, or a CME. And we see a lot of that out in the universe too. So we have to know the type of the star, and then that'll allow us to calculate the stellar wind. And not all O stars are the same. An O1 star is not an O9, okay? And they go O1, 2, 3, 4, 5, 6, 7, 8, 9, okay, or an O0 as well. And then they go B0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's a range of temperatures and stellar properties associated with each section, each type.
To expand on that some, when we, like over on space weather, when they report CMEs and stuff,
yes,
they often say how fast they're moving. How are they determining their speed? Is that with some of the solar observatories that are somehow getting direct measurements off of it?
Yeah, don't forget we have SOHO up there, and we have the Parker Solar Probe. So we're getting information from our sun, and our sun, remember, is the model for everything that we see in the universe. We base what we know about O stars in part on how our sun works, right? So if we know that our sun is going to spew radiation at a certain prodigious rate, in ergs per second or whatever for a certain range or a certain area, well, then we would know that we would have to ramp that up, say, for an O-type star, or we'd have to change it for an M-type star. It'd have to get less, based on the projected energy output of these stars. Well, look at that! Wow, that's not bad. Maybe just a little bit adjustment here like this. Hey, what do you think, guys, for the last gasp of the Rosette Nebula? Not bad. Yep. And that's the Rosette Nebula right there. And Rosette Nebula O. All right. Rosette Nebula. Wow, really pretty. Let's pull out a little bit from this. Well, there you go. There's your Rosette. Now, when we save this, the titling, none of that goes with it, okay? You just get the raw, beautiful image. All right?
You better rename it before you save it.
Oh, I'm gonna.
Okay.
So, see, there's more to the image, by the way, so you can see. That's the image right there. And if we actually, just for a time, let's just pop that over and increase the size. I'm going to show you some interesting stuff in here. And I'm going to remove that name because we don't need that. But if you look, you'll see that there's a really interesting area right here. It's an area of extraordinary ionization in there. that's causing this beautiful red glow in here. That's pretty amazing. And again, just to see it again, now that we have a lot more frames here, we've actually stacked 20. There's our stalks that we were talking about before. Little tiny ones, larger ones. Just dozens of them throughout this nebula. Now you can see what stackling is doing, because now you can see how beautiful this looks. It looks like a painting almost. And I'm among the stars. This is so cool. And another last thing I'll point out here is up here in the nebula, you can see how the stars have literally pushed hydrogen gas out this way. And then there's the stars are all down here. But if you notice, there's these little tiny dark areas, right? Now, I'm going to be clear about these dark areas for you, okay? We're talking about this guy right here. See that guy? And this guy right here. You see that? Those little dark areas have a special name, and those are named for Bart J. Bach, who I had as a professor when I was getting my degree for a short period of time. And Dr. Bach discovered these objects here, and they're very important to the formation, because if you look at this one, it has a tail behind it, you notice? So in effect, we might call it a proplid, okay, a protoplanetary object. This might be something that's actually going to form another star at some point. It's a self-gravitationally contracting object that's getting smaller and hotter in the center, and maybe there's going to be a star formed in there. Maybe a whole star system of planets will form around that at some point. And there's another one here, right? So these two objects are key. There's another one right there. They're all throughout these stellar nurseries. And you can see that this is one big giant chain of dark nebula right here. Sometimes you'll see a disconnection where you'll find that you have another spot, like right here, all right, and right here, all right. And so these are areas where that's all possibly creating more stars and more interesting materials in the universe. Just beautiful.
What did Bach actually discover? I mean, I dare say those dark spots were noted long before whatever he discovered.
Well, he discovered that
he discovered the nature of them?
Yes, he discovered the fact that these are areas where new stars and planets will probably form. All right. They were called Bach globules.
Yes.
I know you know that. I was telling everybody. Ronald, I didn't say hi to you. I'm sorry. You've been here for like an hour, and I apologize. I haven't said hi to you. Hey, look at that. Michael Hedrick's got an Introduction to Stellar Atmospheres and Interiors by Ivan Novotny. Oh, did you give them that name? Errol?
Who?
Did you give them the name of the Ivan Novotny book?
I thought you did.
I did, verbally, but I think he typed it. I thought maybe you typed it for him, but okay. Yeah, Michael, don't get that book unless you have a reasonable physics background. Okay? Because you'll look at it and think, I can't understand what's going on. And, you know, I could be wrong. You might be, better at it than me, for all I know. I mean, that's fine. But I do think that it requires, quite a lot of preliminary understanding to actually understand what's actually going on inside a star. Move this over. Beautiful, though.
Will you excuse me, please?
Sure.
Be right back.
Izabela says the Mars helicopter just flew its 50th flight when they were only looking at 5 possible flights. You're right. And so what we've noticed is that this particular Mars helicopter really has outshined, like you can't believe. If you think about it, all the rovers on Mars that we've landed, all have gone way past their warranty period, haven't they? Okay, Curiosity is still chugging along. Did you know that Curiosity, which I think landed in 2012, is still chugging along? And how about this? It had a 90-day lifespan expected, 90-day expectancy on Mars. 90 days, 3 months. And it's gone, what, 11 years? So when Jet Propulsion Laboratory builds some spacecraft, they don't fool around. They don't fool around. Okay. All right. Okay, so there's 30 shots here. We're going to pause these here. And then I'm going to rename this to the Rosette. And then we'll say goodbye to the Rosette for the season. Okay, we're going to save it. Up it goes. Save exactly as seen. Haha, even if the screen freezes now, even if the computer bombs out now, we've got a gorgeous Rosette Nebula. Because that's only at my end over in Connecticut where I am. It's not happening out in the observatory. The observatory is still chugging stuff up to the server, which is not on my machine. So everything is in good position. All right, great. Wow, what a pretty, pretty shot. All right, so let's go back to our night vision mode. Here we are. Let's get the computer back over here. All right, now let's get away from that horizon. Let's go find something else. This is pretty. The Beehive Cluster. It's absolutely stunning. We're going to go check it out. Here we are. You'll see the stars appear in here in no time. There they are. You can't miss them. This is pink, the Beehive Cluster. What? I don't know why that keeps doing that. All right. All right, let's move it down a little bit and get it centered up and take a shot because it's really beautiful. We're a little bit zoomed in as it is on our screen. But look at that. Isn't that beautiful? Remember I just talked about this. I talked about clusters like the Rosette Nebula cluster still had its nebula around it. This one has left the womb. This one doesn't have any gas around it that is excitable anymore and ionized anymore and glowing. So we now only have this here. Let's move that down a little bit. Okay, so we have the cluster has basically blown away all of the original formation gas that was in it. All right, so let's do a 25-second shot of this guy. It's the Beehive.
What are we looking at?
The Beehive. You like the Beehive.
Oh, okay.
That's the previous one we just saw. That was a beautiful Rosette Nebula. And that's up on the server pretty quickly. And we'll clear this and wait for the Beehive to come in. So here we go. Here comes the Beehive. Yeah, there's the Beehive. We're going to color correct. There we go. All right. This is beautiful. We're going to back out just a little bit and we're going to make the colors of the stars a little bit more obvious. Okay, you'll see some orange stars. All right, here, 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 there, and some blue stars. Now, it makes sense, stands to reason. Sometimes these stars that we see, let me just move the name off for a minute. Sometimes the stars that we see in a cluster are evolving, and they tend to, if they stick around with each other, then there'll be some blue stars. But then as those blue stars run out of hydrogen, they start to go through the next phase of stellar evolution. That next phase is where the core of the star begins to contract and sends out very, very powerful stellar winds when it does that as it gets hotter. And so the star expands and goes into a red giant phase. And so some of these stars, perhaps in the cluster, have gone into a red giant phase. We've seen that in several other clusters that we've looked at in the past. I saw something about a private message earlier, Cosmic Ray. What was that about? Or was that from you? Hey, MLR, how are you? He says, the college astronomy course I had was in 81 and 82, so I can't say I remember much on the technical side. Well, it's just a matter of keeping up with it, right? You can always get it back. Oh, I think Terry is the one that said somebody, Izabela, sent a private message. I don't know who that was for. Okay. Well, anyway, here is this beautiful cluster. You know, these remind me of little gems, little jewels, like a glittering jewel box. Look at that beautiful color. You can't help but be taken by the color of some of these objects in the night sky. And because of stars, you can see the color of the stars because they're so bright that it sets off the cones in your eye that are the color receptors. So you'll be able to see the colors of stars with your eye. It's the colors of nebulae which are much, much fainter that you're not able to see too well. And your eye is most sensitive to green. So looking at a nebula, if there's some ionized oxygen in it, you might see some of the green color of that, like the Orion Nebula. So it's a fascinating trip through the universe when you actually look at all the things. And here's what's going through my head when I'm looking at these things is I don't just see a cluster. I see an evolution. I see a stellar nursery. I see the birth of stars. I see the aging of stars and the changes in the nucleosynthesis, the stuff that's going on in the stars to make the new elements that we see in our periodic table. That's what I see when I see these clusters. I see these stars that are creating elements up to, maybe carbon, nitrogen, oxygen in the interiors. And then maybe the much bigger stars would be doing things like, or creating things like iron 56, an isotope of iron would be created in the core of some of these stars. And then you'll see a lot of that stuff get released into the interstellar medium when there's an actual supernova. So I think that's pretty cool. So this is great. All right, we did 12 shots here. That's good for this one. Let's change it to Beehive up there, so we'll save it. Save exactly as seen. I'm really glad that this computer here in the bunker is cooperating tonight for the moment. It may change. All right. So we'll get out of that. I'll go back to our 1 second night vision mode. There we go. Night vision. Okay. So that's the Beehive. And now, if we back out of that, now we're coming up into the constellation of Leo. And Leo's in good position tonight because there are some things in Leo that are a lot of fun to see. Namely the Triplet. If you want to see the Triplet, you can see the Triplet. That's M96. The Triplet's back here. But we can do 96 and 95.
And 105.
Yeah, and this guy, yeah.
Did you see that image of the hamburger I sent you to? It was an APOD image of the hamburger galaxy.
Yes. Yeah.
And this is ringing a bell. I don't remember which one it was and where I saw it earlier today, but I saw something about the second brightest galaxy in Leo, and I don't remember where I saw it, and I don't remember what its NDC number was. 2903? I don't remember.
Okay.
It's brighter than the usual suspects here we look at.
Well, interesting then.
I was early this morning. I wasn't awake yet. I don't remember where I saw it at.
All right.
Let me see if I can find it.
Okay. So right now we're focusing on this galaxy up here, which is Messier. We got more. There's so many galaxies in this shot. Let me just move around here, get us situated here. All right. Now we're going to wait for our guide star. It takes about 14 seconds to lock on. Once we lock on, we'll initiate a 35-second exposure. Here we go. We'll let it stabilize. We'll come out of night vision in the process. Jump into the stack and take the Beehive and clear it. All right.
I don't think I can find that.
Okay.
Let's see. Not directly.
There we go. We got us some galaxies. There's another one down here too, which we'll be able to check out in just a minute. Actually, just do this. Drop this down a little lower. So, where are we in this sky? Well, let's go. First of all, let's color correct, and let's do a little processing. So we have 1, 2, 3, 4 galaxies that are immediately obvious in this image. But there's another one right here. Okay, and there's more in this image here. So, first things first. Let's go look at where we are. So let's bring up our Stellarium view, center it. Now that red box you see, that represents our field of view. Okay, let's move the name out of the way for a second. All right, so we zoom in here and you'll see that we're focused on Messier 105. M105 if we look at this, zoom in. Okay, this guy here at the upper left. All right, this is NGC 3384. NGC stands for New General Catalog. Okay, and then this one is 3389. Okay, and Messier 105 is this one here. Measure 96 is down here. Yep. Hi, Hunter. All right. I just said hello to my son, who's returned from his work. He works at the television network, the biggest one in the state, which is cool. All right. So this is Measure 96 right here. You'll look at those beautiful spiral arms. Okay. Really pretty. Yep. And there's one right here. And so there's a number of galaxies that we see in this region. Actually, there's so many galaxies that if we zoom out, we're bound to see more. If we if we just go hunting through our field, we'll find more galaxies. Right? So we come in here. There's one right there, very faint. Actually, why don't we just box them in? Okay, so we see one right here. There's one in there. Oh, let's see. There's a faint one right there. There's one right there. Then, of course, we have these three here that we know. So I'll just circle all those. Yeah. Oops, sorry. So yeah, so there's a number of them. There's one right here. Right here. There's a lot of galaxies in this picture. There's one right here. And there's something weird going on right there. I'm not sure if that's a galaxy or something else, but there's a faint object here. There's another galaxy here. Yeah. And there's what looks like one right there. See any more, Daryl, that I haven't seen?
I'm sorry, I was looking something up.
Okay.
I'm a million miles away right now.
All right, there's another one right here.
Oh, I think I remember where I saw that.
Well, you get in the picture, guys. There's tons of galaxies. Now, it's amazing to think that these three here, right, you look at these and say, well, those are the galaxies that are in the picture. No, there's more. Clearly, there's more. I'm not sure what this object is here. That could be actually two stars that are kind of close to each other, making an oblong star pattern. I'm not sure. But there's a lot of galaxies here. A lot of galaxies. Okay, I'm waiting for Starlink. Uh-oh, session interrupted.
Uh-oh.
Yeah. Let's see what's going on with that. And we're back. So never mind.
Okay, I found it.
What'd you find?
The galaxy I was trying to think of earlier.
Okay.
And whenever you're free and feel like looking for another one, we can go find it.
I'm not going to save this. Well, maybe I should, actually. I got this to this point. I've got 10 shots, and I'll take 11. And I'll call this M105. Oh, M105 plus more. I should be. Yeah, you know what? I'll be careful about that. M105 and M96 down below, and I'll leave that at that. We'll figure out the rest. Okay, so we got 12 shots now. That's better. So here we go. Save it, and save exactly as seen. There we go. All right. Now we can clear that. Get out of the stack. Go back to our night vision mode. And move on.
I don't remember what number I said earlier.
Well,
I thought maybe 2903. Look up NGC 2903.
Okay. Why don't we do that?
This is supposedly the second brightest galaxy in Leo.
Okay.
Marianne is here. Hello, Marianne.
Marianne, you shouldn't be here right now. You've got a big, giant talk to do tomorrow. Marianne is part of UAP-PD, unknown aerial phenomenon, as seen by police and law enforcement. And she is going to be doing a talk about this tomorrow. And Marianne, why don't you fill everybody in, give them a little bit of an idea what you're doing. This is NGC 2903. That looks pretty bright. So we're going to go there and check it out. You can watch the telescope move a little bit. This is going to be a nice view because it's almost overhead.
Large spiral galaxy.
Yeah.
In Leo.
Here it is. Hey, Tim F. I didn't say hi to you yet. Sorry. Okay, so let's head a little west. Bring that thing into the center.
Looks like it's not very big.
Well, it's got some outer environs that might be pretty cool looking. Let's just check them out.
Sky and Telescope said it's the second brightest galaxy in Leo.
Is the first a like M96 or something?
He didn't say, but I would assume so.
All right. Okay. We just saw M96. All right, let's do this now. Let's do a 25-second shot and build up a repertoire of these. Temperature's been pretty warm out there. It's been like 90s.
Cooled off there today. It was only in the 70s.
Yeah. Well, it's 16 Celsius out there right now. Let me bring up my live stack. And there we go. Let's check out what it looks like. Get rid of this. That's too much. Oh, look at that. That's really pretty. Color correct. There we go. We can start to zoom on this because that's going to come in really pretty. We've got 2 so far. That's a very obvious barred spiral. What's a barred spiral, guys? It's when you have a galaxy that has a elongated central nucleus like this, and then the spiral arms go off of that. All right, and that's what we're seeing. This is really pretty. Okay, Marianne says UAP-PD is a presentation about law enforcement officers that have seen unexplained objects and have never talked about it. So Marianne has been pulling this information out of law enforcement people who have been hesitant to talk. And she's doing this with David Rich, who is another law enforcement officer. And they are going to be presenting tomorrow. And they're going to be introduced by John Dover and Stan Milford, who are the Navajo Rangers. Navajo Rangers, good friends of ours. You know, these guys are great. And they're going to talk for about a half hour, and then Marianne and Dave are going to talk for the rest of the hour and a half. So I think that's going to be really cool. Yep. So it's basically Basically, a presentation about what happens when law enforcement meets the things that they can't explain. And one of the cases is actually very interesting. It's actually about what appears to be a ghost that actually called 911. And that's something fascinating. It's a fascinating case because it messed with law enforcement people's heads, including Dave Rich's. So, because he was directly involved. Hello, Tricia Ferreira. How are you? She's asking Marianne if it'll be live streamed. I don't believe it's going to be live streamed. Is that correct? Well, Marianne, if you're saying hi to people, there's a lot more people than that here. JSCO, how you doing? I haven't said hi to you yet. Good to see you. Okay, this galaxy is beautiful. Let's zoom in now.
Nice.
I'm seeing some what looks like some hydrogen regions in it. Look at that. This is really beautiful.
It is. First time for me, first time for you too, I guess.
Yeah, that's right. Good music for this one too. Look at these beautiful. There's definitely some H2 regions, these hydrogen regions, these stellar nurseries in this galaxy. You can see them. How beautiful. Wow.
Cool.
Indeed. Let's color correct again. Wow, that's really pretty. And the other thing, guys, when you look at a galaxy, one of the things that happens with galaxies is they have those spiral arms. Now, how the spiral arms form, that's a topic for another night, because there's several ways in which spiral arms are thought to be formed. One of them is a density wave, and one of them is actually a sympathetic interaction with another galaxy. But this particular set of arms is interesting because you'll notice that, like many spiral arms, they tend to be bluer than the center of a galaxy. Now the question is, why is that? Well, a spiral arm is a dense knot of stars. And why is it a dense knot of stars? It's that way because that's where stars are forming. And so they tend to be hot, young, and blue. And so that is why the spiral arms of a galaxy will have these blue knots of stars in them, if not have a blue cast. The older stars are near the nucleus of the galaxy because they've been there for a while. Now, this process that differentiates stars in the nucleus versus the outer arms is based on the age of the galaxy and what we see going on in the galaxy. And these newly formed stars that are in this set of spiral arms are going to tend to be hot and young O-type, B-type stars, some A's. There'll be F, G, K's, and M's as well, because as in our galaxy, there are more M stars, the cooler stars that you can't even see without a telescope. There's more stars that are M-type stars than any other type in the universe. Now, just a note when I just say M-type stars, see all these red stars all over here? See, I'm pointing at them right there. These red stars, these are all M stars. All the faint M stars that you can't see. They're all they're part of that stellar population, and these stars have the most planets around them than any other type of star, predominantly because there's more of those stars in the universe. TRAPPIST-1, for instance, has seven planets around it, all within the distance to the orbit of Mercury around the star. And 3 of those planets are in the habitable zone for that small red star, because the stars are extremely lower output than our sun, maybe 1/100th of the output. So the habitable zone is much closer to the star. So if you're on a star, if you're around a star like that with your planet, there's 2 things that are going on. First of all, you go around your star in just a matter of a few days. All right? And that's your year. We take 365 days to go around our star. Because it's a bigger star, we have to be farther away, so it takes longer to orbit. But for these small red stars, you can go around them in 7 days. So a week is your year. And the other consequence is that one face is always facing the star. They're tidally locked stars, tidally locked planets to the star. Oh, zap! Look at that.
Right through the center.
That's okay. It'll go away. It'll take about 3 exposures or so for that to go away. So the bottom line is that when you have an M-class star like that, your planets are going to be so close that you're going to end up with a tidally locked world, and you're going to end up with a very, very short year. And that tidally locked world is going to have a few caveats with it. The side that's facing the star the whole time is going to be like tropical paradise, depending on how far from the star you are, if you're in the habitable zone. Then you have the ring around the planet where it's always sunset. Always sunset. It never gets beyond sunset. Okay? And that's pretty cool. Now, then you can actually have a side on the opposite side of the planet where you can always do stargazing 24/7. Okay? And of course, the time, the length of a day on a planet like that that's tidally locked, well, that's a bit of a tricky business, because the planet will go around once approximately as it goes around the star. So whatever its year is, that's also effectively a day. Okay, but it's tidally locked, so you can say that on the sunny side, it's always daytime. There is no day or night. That's true. But look at it from the top, and you'll see that the planet goes around one time for the time it goes around the star. So is that a day? Mm-hmm. So it's a bit confusing. Michael Hedrick is full of interesting observations tonight. He says, and to think, even at the speed of light, you could take a lifetime exploring just one galaxy. In fact, even if you could instantly be in any solar system around any of the stars in that galaxy. Yeah, that's actually true, and but it wouldn't be a lifetime. You would probably spend a lifetime traveling just to some of the stars in the galaxy. Okay? If you had technology that would allow you to do that. It depends on the technology. I lecture around the country on a string theory variation of propulsion for ships like that. And these ships would actually be propelled by special particles called KK particles. That stands for Kaluza-Klein. And these Kaluza-Klein particles would allow your ship to punch out of your 4 dimensions, X, Y, and Z, moving through time, and be in a special location, a 5th dimension. And that 5th dimension is a location where the universe is all contracted around you, and then you can punch in anywhere else you want in the universe and be light years away from where you just were. Even with that technology, it'll take you more than a lifetime to go through every star in our galaxy. And we have a fairly small galaxy with 100 billion stars, if the low-end number is correct, which is 100 billion. That's pretty cool. I think there's another one over here. You see that? Yes, no. Right there.
Yeah. Might be a satellite.
Yeah, satellite galaxy.
The upper arm, 2903, appears disturbed.
This one right here.
Yep.
Yeah, it sure does. Yeah.
2903 is a member of the Virgo supercluster.
Yeah.
It was discovered by William Herschel. Took the third, what was he called? The third Baron or whatever of third Earl of Ross.
Uh-huh.
The guy that had the big reflector, the Leviathan of
oh, yes. I remember that.
Parsonstown or whatever.
Yeah.
He was the first one to discover spiral structure in this galaxy.
Wow. So
And
this is
a really cool barred spiral.
NGC 2903, correct?
Yes.
All right, Izabela, 2903. She asked what the name was.
Yes, I told her.
Oh, okay. All right, so this is...
I'm glad I remembered this. I ran
Yeah,
across
me too.
this early when I got up this morning. It's my first cup of coffee. Took me a few minutes to remember where I saw it, but I finally remembered.
Wow.
There you go.
Yeah, that's really pretty. I want to soften the noise just a little. I'm going to back this off a bit. There we go.
Looks like with the barred spiral that it's almost shaping up like what I call a steering wheel galaxy.
Yeah, I mean, let's zoom in some more because I want to point out something to folks.
Not a complete circle, but
Yeah.
that's really interesting.
You'll see here, guys, there's this arc of very blue, like I told you, the blue stars, the blue hot stars. This is probably an OB association, a very hot set of O-type and B-type stars. This reddish thing here is either a star local to us that is seen against the galaxy, or it's in the galaxy. We'd have to look. This looks like, and this looks like over here, as well as this. These look like H2 regions, that is hydrogen stellar nurseries in this galaxy right here. And we'll see them in the spiral arms generally. Yeah. Yeah, so that's really pretty. And you can see this long extended bar in the nucleus. All right, that's what makes this a barred spiral. Okay, is this right here. All right, that's the length of the well, sorry, it's a little too long, but the length of the nucleus is actually right here to here. Right. So if it's that long, from like here to here, okay, you can see the spiral arm, which comes off it right here. It comes out like this. It goes out and around. And then right here, we have a spiral arm which comes up and off of this too, but it's a little bit disturbed, as Daryl said. And it keeps coming around. But that's the basis. So you have a central bar, and then you have one big arm off one end and one big arm off the other. And then you'll have supplemental smaller arms that are kind of in there as well. But we can see this one here.
Well, the arm I was talking about is the one at the top left.
Yeah, you're talking about this guy. I know that.
Yeah.
Yeah. Yeah, that's cool.
Well, that's a nice first one for me tonight.
Yeah.
You too, no doubt.
Yeah, I haven't seen this one before. This is great. All right, well, this is enough exposures. I'm going to go to 40 here. We've been talking about it for a while. And once we get to 40 of NGC 2903, we're going to hit save. There we go. Save exactly as seen. The satellite trail's all but gone. But there we go. That's really cool. And we'll come back and let's go to something else while we're at it.
Thank you for indulging me.
No, that's wonderful. It's a good object to go to. Okay, and here is the night vision view of that. We'll just pop out a little bit. Okay. Okay. And let's see here. We are still in Leo.
So you did 95, 96, and 105, didn't you?
I did. Now I'm going to do the triplet down here.
Okay.
And we'll see the hamburger galaxy. Go ahead, do your wimpy impression. There we go. If I could have a hamburger today, I'll gladly pay you Tuesday.
Not now, Wimpy.
All right. So we'll see the galaxies show up in here. See where we're going. Oh, can't miss them. Hamburger and 65, 66, or one or the other. All right, let's head west. Even in our night vision mode, you can see the broad, dark line of dust across the center of this galaxy. That's called a dark lane. And most galaxies that have any kind of spiral structure will have those in them. Very nice. Okay, and so this is going to be the Leo triplet. All right, the Leo triplet. Put that right down there. Okay, now let's, now that we're guiding on this, let's do a 30-second exposure on this. There we go. And we're going to kick off the night vision and bring in the live stack, where we will then clear the last galaxy that we saved up there, which was NGC 2903. That really did come out pretty. Look at that.
Yeah.
Pretty amazing. And there's definitely a companion galaxy out here. Very much so. Okay, we're going to clear it now. And it will be replaced by this set of the triplet images. Look at the hamburger. Yeah, really pretty. See all the noise? You know, you see that noise, but then it goes away. All right, when we get the second photo in, you'll see that noise go away. And it'll get much less, and the galaxies will be more clear. Michael Hedrick says, "Yay, I love the triplet. If I'd let you see it, though, right? Let me just back out a little. There we go. See, that triplet's beautiful. And each of these galaxies has a particular flavor to it, right? This galaxy looks like it's had some kind of turmoil. This galaxy looks like it's had some turmoil. And this one looks untouched. Isn't that amazing? Okay. Let's see if we can coax some more data out. If we come way down, you'll see into the middle of the galaxies. That's really cool. Look at how much detail now. By pulling away some of the over brightened areas, we can actually start to dig into these galaxies and see some amazing stuff in there. Look at that. That's just a processing thing, because we can bring it up really bright. It blows it out. This looks like a steering wheel galaxy too.
Well, that one looks very disturbed.
It does, but it looks like it's a barred spiral. This looks like a regular spiral. And this one, the hamburger, called the hamburger for obvious reasons. It looks like one.
Looks like they put a lot of lettuce on it.
Yeah, right. It's sticking out on the edges. Okay, so now I'm going to bring this over, darken up the background a little bit. We still have some noise, which I can correct and get rid of some of the noise by doing this. But I prefer the unsharp mask. All right, that's good. Just drop down here. So imagine if you were in this galaxy looking at that galaxy. It would be huge in your sky. And from this galaxy, these two are going to be relatively huge in your sky too, because they're not, I don't think these galaxies are really all that far from each other, but I'm going to go see what we got here. That might be something to get out of this. Okay, this one is 45 million light years away. This one, measure 66, is 35 million light years away. And this one, it doesn't give a distance. Well, can you find out how far M65 is?
Yeah, just a sec.
So 44, 35, and probably similar. That's pretty cool.
Uh, 35 million light years for M65.
Okay. So about the same, yep. Take the name out of there. Bam. Okay.
66 is also 35.
Yeah.
So, I don't know if we could really extrapolate any distance between the two, but, you know, if they're both about the same distance from us,
Well, then
and the
there's
separation like what we see, then they're going to be relatively close.
Yeah, this is what you're seeing. So, knowing the size of the galaxies, we could extrapolate the distance between them. And we probably calculated the distance by using Cepheid variables in these galaxies. Let's do a color
Article
correction.
on Leo Triplet says they're all about the same distance away.
Yeah, the hamburger they say is 40 or 44 million, but this,
Yeah.
what that means, guys, is that these are close enough to basically interact with each other, or to have interacted with each other. Not bad. Nice. Let's zoom in on Measure 65. This is nice. We've got 13 frames stacked here. You can see its dark lane, kind of on a edge to us like this. It's sort of angled to us with its face. This one here, Measure 66. This one has a lot going on. You see bright blue objects in here. Those are probably OB associations. So we're seeing them here and here, to a lesser extent here, and some down here. So there's a lot going on in this galaxy.
Mm-hmm.
Yeah. Indeed. So that's really neat. A really beautiful galaxy. And let's go zoom in on the hamburger, shall we? And there's our dark lane, but you'll notice something interesting about this dark lane. This dark lane actually does a weird breakup near the outside edge, which I'll show you. It splits into many filaments. You see that? Like a splash. It's really kind of weird. And then
it kind of fans out toward the right side.
it does, doesn't it? Which implies an interaction. And many times what happens with galaxies is their disks can get warped by other galaxies nearby. So, like from the top, it'll look like this, but from the side, it might look like this, where the galaxy's disk is kind of going down like that, guys. You know? So, it's just amazing. And of course, for those who may not realize or haven't thought this part of it, we're looking at these galaxies that are way, way out in the distance and through the stars, which are all up here in our galaxy. So every star you see in this image is right in front of our face, effectively, and those galaxies are way beyond it. Pretty cool.
I sent you that APOD image if you'd like to show it. You can really see what's going on in there. You can see a lot of smaller galaxies also.
All right. Okay, so this is that galaxy. Really pretty.
Something's obviously distorted that galaxy.
Very, very clearly, yeah.
Gravitational interaction of some sort.
Well, this thing here is probably part of it.
Yes.
So that's neat. Well, thank you for that.
Yeah.
And then if we come back and look at this, all right, if we zoom in, we can see there's a lot going on in here. Absolutely.
Thank you, Terry.
Prowl's
Well,
hungry now.
Looking at
so
the
is
three
Terry.
there.
Yeah.
I'm sorry, say again.
No, go ahead.
Looking at the three, I mean, M65, the one at the bottom right,
Yes, right here.
it looks the least disturbed.
Yeah. That's what I was mentioning before.
Yeah, if,
Looks like these two may have interacted,
yeah,
and this one may have just joined the crowd of late.
yeah,
Yeah.
kind of what I was thinking. And there were other galaxies in that field. I see a little dim one over to the middle left, right there.
Yeah.
And there were others in that APOD image too.
Yeah.
One looked like a satellite right beneath the middle of the hamburger.
Yeah, I can see it right there.
Oh.
Yep.
It's getting crowded up there.
It is. It is. All right. Well, let's redock this. Let's redock our starship here, and let's take a ride to something new. We've got many of these stacked. Let's save these. We got 24 stacked. So we'll change this to the Leo Triplet. And we'll save it. Exactly as seen. Okay. And one more save, but with a little bit more contrast. Here we go. Now we'll save that exactly as seen. And now it's saved. Excellent. Okay, we'll get out of that. Jump to our... Are you guys having a good time tonight? Because it's really... It's an enjoyable ride. It is really an enjoyable ride. Okay. Okay. And let's get our night vision mode up. And let's zoom out a little bit.
Thank you, Terry. Thank you, Tricia. Thank you, Izabela. Well, we're getting down there now. Is it still too early to worry about trying Virgo cluster?
Oh, let's find out. Because that's kind of where I'm laying in a course here in the Enterprise.
Somebody mentioned the antennae galaxies earlier, which are down below and to the right of Virgo.
Just near Crater. Or Corvus. Can't remember.
Yeah, Corvus.
Okay. Oh, we're gonna let's look at the silver streak. In keeping with the hamburger. That's NGC 4216. Let's see if we can see that one. If we can't see it, then we'll have to wait till later in the season, but I think we'll be good.
Yeah, getting around the west edge of the cluster at any rate.
Yeah. Well, there it is. Okay. Well, we're good now. Let's do this. Bring it down. Head west. Okay, and let that settle out. Excellent. All right. So now we're guiding just fine. You'll see there's galaxies in here. As we come in here and do a 35-second shot, you'll see that we're going to start acquiring data. And this is the Leo Triplet. Beautiful color, huh?
Yes.
It looks pretty. So that's going to be up there momentarily if it's not already there.
Izabela says it is.
And that's fantastic. Oh. Thank you, Izabela. And by the way, we're working on a special project for all of you. We're not going to talk about it right now, but although I just did, didn't I? But it is interesting. Okay, this is...
Jeez. what do you call that? A teaser?
Yes.
Okay.
Yep. We're working on something interesting for everybody. Okay, look at this, guys. We have galaxy here, galaxy here, galaxy here, galaxy there, there, and there. We're getting toward the Virgo cluster. So we have tons and tons of objects now. Let's go look over here. It's actually, it's almost hard to tell where you are sometimes. There's so many. Okay, so this guy, let's move this over a little bit. So you see this galaxy, and then that galaxy. That's over here on this image here. That's this galaxy, and this galaxy. Those three. And there's one there, a beautiful spiral looking structure. Amazing. Let's do a color correction. Then let's try to process a little bit more of this. That's a beautiful field. So now you're seeing so many galaxies in one view. And what we'll do is we're just going to go to 5 exposures on this, and that way I'll leave them for you to do a galaxy count. And don't forget that little guy right there. Okay. Okay, let's see here. All right, there's 5, so we're gonna save it. Oh, I messed it up. So let me fix that.
Well, darn it.
That's okay.
When we looked at NGC 2903 earlier,
Yes.
even though it was over on the western edge of Leo,
Yes.
it's a member of the Virgo cluster. And now we're all the way over here. We're still on the west side of the center of the Virgo cluster. We're still sort of in the suburbs, but the thickest part of the cluster is still off screen to the left.
Yeah, we're gonna try and go look for it. See how far away we are. So now we're gonna back out and we're gonna come down here. I think we should be able to see all this.
Try.
All right, we're gonna go to Markarian. Actually, I'm gonna just tell it to go to that location in the sky, and then we're going to see a huge number of galaxies out of nowhere. You can start to see them already. Obviously, the crosshairs are our telescope moving into position. Okay. This is called Markarian's chain over here. It's a number of galaxies. And I have to check something here. We'll zoom in on this here. Yeah. Okay. We're going to move up a little bit. Okay. All right, so this is another in the study of how many galaxies can you find in one photo. This will be a 30-second shot. That's all we need for this location. We're still searching for our guide star up there. And when we see all the zeros, it shows that we're beginning that process. I'm going to move west a little bit. Okay. Waiting for our guide star here. This might be the Virgo galaxy here, M87. I'm not sure. It should be just off out of view here, but I don't see that it's out of view. Okay,
It's in the neighborhood, I know.
Yeah, it is. It's down to the lower left. Okay, we're calibrating and guiding now. So we'll start the 30-second clock right now, where it looks like we're stable. Off we go, and we'll come back into the live stack and take the Silver Streak Galaxy and its attendant galaxies. And I believe we saved them all, so we're good. And this is going to be what we call Markarian's chain. These are galaxies. GAL. So here comes the first one right now. That's beautiful. So we see many different types of galaxies in the same view, okay? And as time goes on, we'll see some nicer images of them as we stack some more. But let's get rid of that glow, that purple, and let's now do a little processing here. Okay. Again, in the game of how many galaxies can you see? You got quite a few. Don't forget that one when you're going to count it either. Look at that little guy. And that little guy. And that little guy. And stars that look fuzzy might be elliptical galaxies. Okay? Like this one looks fuzzy. That may be a galaxy. Elliptical galaxies can be round balls of stars millions of light years away. And that's something that we have to be careful about. Interesting. Let's see if we can get a little more contrast out of this. Let's see if we can drop down. You can see how many different galaxies are in here very quickly.
I think that is M87 on the lower left.
Yeah. There's another little galaxy right there. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and I don't know if I got these, 18, 19, 20.
There's like a row of them up on the
21.
upper right. The bright ones.
Yeah, these guys.
That's M84, M86, M84 on the far right, M86 in the middle, and the one to the left is
The eyes. Those are known as the eyes.
4473 and 4477. Maybe the eyes.
There's a beautiful one right here. It's got this beautiful coloration to it.
4461, 4388. Yeah, and that's M87 over at the lower left.
Yeah.
Out of view at the moment.
Yeah, because I have to drop it down, but there it is.
Yeah. That's the one with the big black hole in it, folks, that the Event Horizon took the image of.
Yep. That's the black hole that's 5 times the size of our solar system.
Yeah. We've zoomed in on it before and could actually see a little bit of the
Jet.
The jet coming out of it.
Yeah.
I don't know if we'll see it tonight or not.
If I do, we're going to have to drop this like this. I don't see it. But then again, I see that we may want to refocus too. Of course, that's way down to the lower left where things tend to be. It might be a little bit dragged now. Let me look in the center here. Let's see what we got for focus. Oh yeah, we're out of focus. Okay, we can fix that. All right, we're going to fix that. So we'll fix the focus right now and then do this again. Okay, night vision mode. And let's take it out of focus.
Excuse me a sec while you refocus.
Yeah, no problem. When you take stars out of focus, you can actually see their colors very well. And that's something that we do from time to time. Okay, let's do the focus again. We're going to scan in. And we have 30 stars now. Now 27, 24, 49, 52 as it gets more in focus. Then as it gets, see it's 66 now. You can see that right over there, right here. Right here. Tells you the number of stars it's using. So you'll have 84 little squares now in this image. And it continues on down here. And you can see our curve is starting to form. At the bottom of the curve, that's the best focus. And as this comes up, you'll see a line right about now. Just pop in there. And that's going to be the best focus. There it is. And we can just jump right to the best focus now, because we know what it is. All right. And now, one more time, we'll do a 25-second shot. And come out of night vision mode, go back into our stack. And now we'll see these even clearer than before. All right, so that's good. So we'll clear that out. Start to stack over. And this is going to be Markarian's chain. Okay, now let's check it out. All right. That galaxy has the coolest black hole in it. I love seeing how that was captured. Okay, let's try to pull way down in the data. Now we can see just a hint of that jet right there.
Can you see it now? Is that what I see?
Right there.
Yeah.
So that's the jet sticking out of Mesher 87 right there, guys. Invisible unless you process it, as you can see.
There's a Hubble picture with M87 that shows the jet sticking way out.
Yep. So this is really interesting because you follow the chain of galaxies. That's why it's called Markarian's chain, right? And you see where they go and how they form. This galaxy here was the one I was primarily interested in because I wanted to see that up close. And we can see it's got some really defined lines in it, which kind of reminds me of a starburst galaxy. Really cool. Okay, let's do a little process. Add some contrast. Very nice. Oh, Michael Hedrick, this is your personal spacecraft. Yeah. And everything in the universe, in our area in the universe, is all heading toward this area in space. The Great Attractor. And the Virgo cluster is a cluster heading in the same direction. All right. That's really pretty. I really like this galaxy.
We're falling toward the Virgo supercluster, and the Virgo supercluster is falling toward the Great Attractor and taking us with it.
Yep. Look at that. Look at that. That line. It looks markedly red, and I'm wondering if that's actually just a dark lane, or if that's actually a strange artifact of a starburst galaxy. Really cool.
I imagine in a supercluster like that, all the interactions going on, that there must be all sorts of fireworks happening.
I think so. Alright, we're going to save this one here, because it's 1:09 a.m. right now, and later on in the season we'll be able to see this right as we start. But for now, let's just zoom out and see everything we captured. There it is. So this is the whole area near the, sort of near the center of the Virgo cluster. If we actually pull this down like this, really compress this, and move this in, increase the contrast, you can see something really interesting stuff going on here. Really interesting.
That galaxy looks very distorted.
It does.
If you zoom in on it, you can see it.
It's true, it is.
Looks like it got stepped on.
Oh yeah. Yeah.
Are those two the eyes you said?
Yes. I believe those are the eyes right there.
They're M84 and M86 look like eyes with a nose and a mouth just below it.
Yeah, but I think those are labeled the eyes. Let me just go look.
Yes, I know. I'm just saying that
Oh, okay.
if you pull back out and get M86 and M84 in the field,
Yeah.
there's two more galaxies that make it look like a face.
Yep.
See, the horizontal one there at the bottom right is the mouth, and that little round one in the middle is the nose, and then there's an eye.
I don't think the inhabitants of these galaxies would be happy knowing that you said they're a nose.
Oh well. I won't tell them if you won't.
I don't think we could ever tell them.
Oh, can you back out just a hair more?
Yeah.
Keep going. There, you see the face now?
That's the mouth?
That's the mouth. Above it's the nose, the little dot.
Right there, and then the eyes.
Uh-huh.
Yeah, I see it. And it's got a little tiny Charlie Chaplin hat on.
All right, okay.
And he's
I don't
extending
think
his
those people
hand.
would appreciate it. Or they'd probably go, what's a Charlie Chaplin?
Look, he's got an arm extended too, because he's doing a dance. You know, like the frog in the Bugs Bunny cartoon. Oh, baby. And then it just goes when the guy says, show him. Wow. Okay, well, let's save this. 22. And then save exactly a scene. Okay, that's good. Very nice. Oh, uh-oh. There's that music. Well, folks, I think we're going to have to call it for tonight. This has gone on. We've done this for... I gotta find my timing on here. I don't see times anymore on this. But we've had to go for well over 2 hours already, haven't we? Maybe 3? Oh, I think so. Gosh, a long time. 10:30, 11:30, 12:30, 1. Yeah, over 3 hours. Well, folks, thank you for coming out and hanging with us at the SkyTour live stream. Had a great time with you tonight, and I look forward to doing this again with you on the next available night. So you guys have a good night. And if you have any questions, remember, go to skytourlive.org and contact us through that. Or you can go to our Patreon and join our Patreon and bring us some, show us some love. We'd love to have you join our Patreon. Okay? So check that out if you will. And again, I'd like to thank our patrons so far. All right? Our patrons are wonderful people: John P., Izabela M., Ollie B., Chief McCyber, Vera C., Ronald T., Martin W., Raymond B., Cindy M., and Terry H. And that number will only climb from here, I suspect. And the more it climbs, the more we can do for you. So you guys have a good night. Great to see you, and we'll see you again soon.
Good night, everybody.